Welcome back for another deep dive. Today we're going to be looking at something really cool in the world of AI image generation.
Okay.
You know, like all those AI models that can create those stunningly realistic pictures
Yeah.
from just a text prompt.
Right?
They're amazing, right?
Yeah, they're really something.
But they need a lot of computing power.
They do.
We're talking like server farms,
Mhm.
the whole 9 yards.
Yeah. You need a lot of juice to make those things run.
Yeah.
It's true, these models are incredibly complex.
But what if you could shrink them down,
Okay.
like make them way more efficient,
Mm,
but keep their image generating abilities like the same?
right.
Would that be amazing?
Yeah, that would.
Well, that's what researchers have done
Oh, wow.
with something called 1.58-bit FLUX.
1.58-bit FLUX?
Yeah, and they've managed to reduce the model storage requirements by 7.7 times.
Wow. That's a huge reduction.
It is.
That's right. It's a fascinating breakthrough that can make these AI models accessible to way more people.
I'm trying to wrap my head around this 1.58-bit thing.
Yeah.
It sounds like barely any information at all.
Right.
Like, how can it even function with that little data?
Well, the key is a technique called quantization.
Okay.
Imagine a painter with like a palette of millions of colors, right?
Mm-hmm.
Quantization is like saying, hey, let's simplify things a bit.
Okay.
Instead of all those subtle shades, let's group them into like a few core colors.
So instead of using a vast range of values,
Right.
1.58-bit FLUX just limits itself to a few key values.
Exactly.
So that seems like it would really simplify the calculations.
Exactly. And that's precisely what the researchers did.
Wow.
They've constrained the vast majority of FLUX's 11.9 billion parameters
Okay.
to just 3 values.
Wow.
+1, -1, and 0.
So that's it?
Yeah.
Just 3.
It's a radical simplification, but the results are really remarkable.
I can see how that would be more efficient, but I'm skeptical about the image quality.
Okay.
I mean, simplifying it that much, there has to be some trade-offs, right?
Right.
Like the images must be less detailed or something.
You're right to question that.
Yeah.
It's natural to think that reducing precision would lead to a drop in quality.
Mm.
But what's fascinating here is that 1.58-bit FLUX actually maintains performance comparable to the original full precision FLUX model.
No way.
Yeah.
Seriously.
Yeah, they really did it.
That's incredible. How is that even possible?
Well, the researchers rigorously evaluated 1.58-bit FLUX
Okay.
using industry standard benchmarks like
Yeah.
Geneval and T2I ComBench.
I've heard of those.
They're like standardized tests for AI image generators.
Uh-huh.
They measure how well they perform against certain criteria.
Right.
And guess what? The 1.58-bit model consistently produced images
Yeah.
that were nearly indistinguishable from those generated by the full precision model.
Wow. I wouldn't have believed it without seeing the evidence.
That's really something.
So it's not just about shrinking the model itself.
Right.
They found a way to make it more efficient without sacrificing much, if any, quality.
Exactly. And this has really big implications for the accessibility of AI image generation.
Yeah.
Think about it. If you can reduce the storage requirements that much,
Right.
you can start running these powerful models on devices with much less storage.
Like smartphones and tablets?
Exactly.
That's crazy.
It is. Imagine the possibilities.
Yeah.
Artists could use these tools on the go.
Right?
Designers could rapidly prototype ideas.
Uh-huh.
And everyday users could access sophisticated image editing capabilities
Mm-hmm.
right from their mobile devices.
Wow.
It opens up a whole new world of creative potential.
I'm getting really excited about this.
Yeah, it's pretty cool stuff.
Okay, so we've established that shrinking the model itself is amazing.
Right.
But are there other ways to make it run even faster on these smaller devices?
That's a great question. And the researchers didn't stop at just quantizing the model's parameters.
Okay.
They also developed a custom-designed kernel specifically for these 1.58-bit calculations.
Okay, what is that?
Well, think of a kernel like a piece of software that's optimized to execute specific types of computations really efficiently.
Okay, so like a specialized tool.
Yeah, kind of. That's a great analogy.
Yeah.
This custom kernel further reduces the memory usage during inference by over 5.1 times.
That's awesome.
So it can process information and generate images even faster,
Right.
even on devices with limited resources.
So not only did they shrink the model itself,
Right.
they found ways to make it run smoother on less powerful hardware.
Exactly.
This is starting to feel like sci-fi.
It's remarkable how quickly things are advancing in this field.
It is.
And there's even more to the story.
Really?
So far, we've been talking about quantizing the model's parameters.
Right, those values that determine how the model processes information.
Exactly.
Okay.
But there's another layer of optimization we can explore.
Okay, what's that?
Quantizing the activations.
Hold on, quantizing the activations.
Yeah.
We already compressed the model itself.
Right.
What else is there?
Remember how we talked about quantization being like simplifying a painter's palette?
Yeah.
We did that for the model's parameters.
Yeah.
Essentially, it's internal settings.
Mm-hmm.
Now, imagine applying that same concept
Okay.
to the information flowing through the model
Okay.
as it generates an image.
Uh-huh.
Those are the activations.
So instead of using a wide range of values for those activations,
Right.
we'd limit them to a smaller set,
Exactly.
just like we did with the parameter.
Precisely.
Okay, I see where you're going with this.
By reducing the precision of those activations,
Mhm.
we can potentially save even more memory
Okay,
and speed up computation.
I see the potential there, but wouldn't that also affect the quality of the images?
Yeah, that's the challenge with quantization.
Yeah.
Finding the right balance between efficiency and accuracy.
Mm-hmm.
If you quantize too aggressively, you risk degrading the model's performance.
Right.
But if you do it carefully,
Yeah.
you can achieve significant efficiency gains without sacrificing much quality.
So it's a delicate balancing act.
It is.
You got to figure out how much you can simplify the data without messing up the image.
It's a really interesting area of research,
Yeah.
and there are lots of different approaches being explored. Some methods even use adaptive quantization.
What's that?
This is where the level of precision changes dynamically,
Okay.
based on the characteristics of the data being processed.
So the model could use higher precision for more detailed parts of an image
Yeah,
and lower precision for less critical areas.
precisely.
That's really smart.
It's like a painter using a fine brush for details and a broader brush for the background.
Okay.
It's all about using resources efficiently.
This whole idea of quantizing both weights and activations is pretty mind-blowing.
It is.
It could lead to some serious gains for these large AI models.
Absolutely. And there's another dimension to this.
Oh, what's that?
Hardware optimization.
Hardware optimization.
Yeah.
We've been talking about software this whole time. What does hardware have to do with it?
Well, we can design specialized hardware architectures
Okay.
that are specifically optimized for running these quantized models.
So instead of relying on general-purpose computer chips,
Right.
we could build chips
Mm.
that are specifically designed for these simplified calculations.
Exactly.
Okay, I get it.
These specialized chips could potentially execute quantized operations much faster and more efficiently than traditional hardware.
I see where you're going with this.
Yeah.
Custom hardware combined with quantized models could lead to a huge leap in performance.
Absolutely. And just imagine the impact
Yeah.
that could have on bringing AI capabilities to even smaller and more power-constrained devices.
Like,
We're talking about potentially embedding AI into everyday objects.
whoa, AI-powered toasters, here we come.
That's right.
But seriously, the implications are huge. It feels like we're on the cusp of a new era
Yeah.
of AI accessibility.
And it all comes back to what we were talking about earlier. The importance of making AI more practical and accessible for widespread adoption.
Right.
By making these models more efficient.
Yeah.
We're removing barriers to entry
Uh-huh.
and enabling all sorts of new innovations across industries.
It's like we're democratizing AI.
That's a great way to put it,
Yeah.
putting these powerful tools into the hands of more people.
And it's important to remember
Yeah.
that all of this is happening so fast.
It is. The field of AI is constantly evolving,
Yeah.
with new breakthroughs and innovations emerging all the time.
So you're saying we should buckle up?
Yeah.
Because the ride's only going to get more wild.
You got it. We're just scratching the surface of what's possible with AI.
Before we get too carried away with the future,
Okay.
let's bring it back to 1.58-bit FLUX.
Right.
We've talked about its efficiency.
Right.
But what about its practical applications?
Yep.
Like, what can people actually do with this technology?
Yeah, it's a great question. This isn't just theoretical. 1.58-bit FLUX, with its ability to run on more accessible hardware,
Yeah.
has the potential to revolutionize a lot of different fields.
Okay. Give me some examples.
Sure.
Like, what are some of the most promising applications?
Let's start with the creative industries.
Okay.
Imagine artists and designers using powerful AI image generation tools directly on their tablets or laptops.
Right.
They could quickly sketch out ideas,
Okay.
experiment with different concepts,
Yeah.
and bring their visions to life in ways that weren't possible before.
That would be amazing.
It would.
No more needing a high-end workstation just to play around with AI-generated imagery.
Exactly.
Yeah.
And it's not just about professional artists either.
Right.
This kind of technology could empower anyone to express their creativity,
Yeah.
regardless of their technical expertise or access to expensive hardware.
So it's like putting a digital art studio in everyone's pocket.
Exactly.
That's awesome.
What else? Another area with a lot of potential is a mobile image editing. Imagine being able to use sophisticated AI-powered tools
Uh-huh.
to enhance your photos,
Yeah.
remove unwanted objects, or even generate new elements
Oh.
directly on your smartphone.
No more struggling with clunky mobile editing apps.
No,
You could have pro-grade AI tools at your fingertips.
that's the idea.
That's amazing.
The possibilities don't stop there.
Really?
Think about augmented reality applications.
Okay.
With efficient AI models running on mobile devices,
Mhm.
we could create really immersive and interactive AR experiences.
Wait, so you're talking about being able to overlay AI-generated images and objects onto the real world in real time?
It's closer than you think.
Wow, that's crazy.
And as these models continue to improve and become more accessible,
Right.
we can expect to see even more innovative applications emerge.
This is mind-blowing stuff.
It is.
It feels like we're on the verge of a major technological shift.
Yeah, it really does.
And 1.58-bit FLUX is leading the way.
I think so.
It's an exciting time to be following the developments in AI.
It is. Who knows what the future holds?
I'm eager to find out.
Uh-huh.
But before we wrap up,
Okay.
I want to touch on something that's been on my mind.
Right.
We've talked about all the potential benefits,
Right.
but are there potential downsides we should be thinking about?
Ah.
It's true, we often get so caught up in the cool new tech stuff
Yeah.
that we don't always think about the downsides.
Right.
I mean, there's got to be some catch to making these AI models so much more efficient, right?
Well, it's less about a catch, I think,
Okay.
and more about recognizing that no technology is perfect.
Okay.
There are always things to consider
Mm-hmm.
as AI models become more efficient and accessible.
Right.
We need to make sure they're being used responsibly and ethically.
You're talking about like copyright concerns
Yeah.
and the potential for misuse, right?
Exactly.
If anyone can create realistic images
Mhm.
with AI,
Mm-hmm.
it could be used to spread like misinformation
Yeah.
or create deepfakes.
Right, and those are important discussions to have. Yeah. As this technology keeps developing,
Mm.
it's crucial to develop guidelines and safeguards to mitigate those risks.
Okay.
But I really do believe that the potential benefits outweigh the challenges.
Okay. I can see both sides.
Yeah.
But before we get too deep into the ethics,
Okay.
I want to go back to the technical stuff about 1.58-bit FLUX.
Okay, sure.
We've talked about the theory,
Right.
but have you seen any actual images
Yeah.
created by this shrunken AI?
Absolutely. The researchers included some really cool visual comparisons in their paper.
Good.
And what's really interesting is that
Yeah.
1.58-bit FLUX consistently generates images that are visually comparable to the original FLUX model,
Okay.
even with the reduction in parameters.
So we're not just talking about blurry pixelated messes.
No, not at all.
These are actually good images.
They're high-quality images.
That can hold their own against the originals.
Absolutely. Check out Figure 1 from the paper.
Okay.
It shows side-by-side comparisons
Mm.
of images generated by both models. Using the same text prompts.
Cool.
The differences, if there even are any, are super subtle.
Wow, you're right. The images generated by 1.58-bit FLUX are really detailed
Yeah.
and vibrant. Look at the one for the prompt.
Okay.
A cat made of seawater walking in a library.
Yeah.
Both models captured that surrealism,
Right.
and the 1.58-bit version even got the translucence of the water cat.
It did. It's impressive how well it maintains that level of detail and visual fidelity.
Yeah, and it's not just this one example.
Right.
Figures 3 and 4 show the consistent quality across all kinds of prompts,
Yeah.
from simple objects to complex scenes.
Exactly.
I'm looking at the prompt,
Yeah.
a photo of a blue tie and a pink dining table.
Yeah.
Both models nailed it.
They did.
Even the textures and lighting.
Yeah.
The 1.58-bit FLUX image maybe has a slightly smoother texture on the tablecloth,
Okay.
but you can barely notice it.
That's the point. This level of quality is achieved with way fewer computational resources.
Right.
1.58-bit FLUX uses just 2-bit signed integers to store those weights. Okay.
Leading to that 7.7x storage reduction.
It's crazy. It's like they fit all the richness of the original model into a tiny package.
Yeah, it's really impressive.
It makes you wonder if we even need those big resource-intensive models anymore.
That's a great question, and it really challenges the idea that bigger is always better.
Hmm.
This research shows that we can get awesome results with smart optimization techniques.
Right.
And this is just the start.
This whole deep dive has been really interesting.
Yeah, me too.
1.58-bit FLUX is amazing.
It is.
It's efficient, effective, and it has so much potential.
It does.
I feel like we've just scratched the surface.
I totally agree. The most exciting part is that this is just one example of the incredible stuff happening in AI.
Yeah.
As research continues, we're going to see even more efficient and powerful models,
Right.
unlocking new possibilities that we can only imagine right now.
So what's the one key takeaway you want listeners to remember?
The main thing is that the future of AI isn't just about bigger and more complex models.
It's about making AI more accessible, more efficient,
Right.
and more practical for real-world use. 1.58-bit FLUX is a great example of that.
Yeah.
And it's a sign of even more incredible things to come.
Well said. And to all our listeners,
Yeah.
if this deep dive has made you curious about AI, I encourage you to check out the research we talked about.
Definitely.
You never know. Maybe you'll make the next big breakthrough.
You could.
That's all the time we have for today.
Okay.
Thanks for joining us.